Welcome to the Chapter 5, Part 1 video. Chapter 5 is all about polynomials, and we'll be expanding on the previous few chapters that we've taken a look at. So what this video will cover is reviewing some of the functions that we've already seen in previous chapters, defining polynomials, classifying them, graphing them, looking at their end behavior, and then finally a quick review on factoring. So functions that we've seen before. We started out looking at expressions and equations at the beginning of the year, and we use that information to build up and add to our knowledge about linear functions. And linear functions were in the form y equals mx plus b. Or we can think about this as ax plus b, right? Where a is the slope in this case. And then we said, okay, but when we have linear functions, we had two special cases. We had horizontal lines. Now horizontal lines, notice, still pass the vertical line test. So these are functions. And these are what we call constant functions. Y equals c, where c is just a number, right? So this could be something like y equals 3, for example. The next type of linear functions that we looked at were vertical lines. And we said, well, vertical lines do not pass the vertical line test. So vertical lines are not functions. And if we were to write an equation for a vertical line, that would be x equals c. So there is no y, which means there's no f of x, which means not a function. Okay, so that's kind of a way to remember. Horizontal lines are functions, but vertical lines are not. And then our most recent chapter was about quadratic functions. And we said quadratic functions we can always have as y equals ax squared plus bx plus c. So if we look at a comparison, notice we've been just kind of adding a term as we're going along. So we had y equals just a number. And then we said, okay, that would be a constant function. And then y equals a number plus something with an x. Ax plus b, for example, was linear. And then we built up on that again and we said, well, now what if I add another term, this time an x squared, ax squared plus bx plus c, and that we called quadratic. Now a polynomial is anything of this form. So all three of these fall into the classification of polynomials, but we could add even more terms. So I could add something times x cubed and something times x to the fourth and so on, and all of those are polynomials. So we can define a polynomial as any function p of x where we have a number times x to a power. And then we can have all of these terms where the powers are decreasing. Now I know this notation is, if there's a lot of variables, there's a lot going on in here, but what that means is anytime I have a function f of x or y, that's just a number times x to a power. Let's say the fifth power. And then I can have another number times x to the fourth power plus another number times x cubed. And so since these can all be different numbers, instead of just calling them a number, we can call them letters. And usually we just use the alphabet starting with the highest power and keep going. So A, B, C, D, then the power goes down, x squared, E, x, and then we already used f of x, so I'll call this G. Okay, now what letter we use is not as important as seeing the pattern here. So what I want you to do is come up with a couple of examples in your notebook of things that you think are polynomials. I wanted to remind you that when we had quadratic functions, something like f of x equals 7x squared plus 2 is still quadratic. So when we looked at this in the last chapter, we said, well, the x is missing. It's really just a plus 0x, right? So we don't have to have every exponent, every power accounted for, but we can't have something like a square root of x in there. Okay, so polynomials, any polynomial in your notebook, hopefully you've had a chance to write something down. I'm going to give you a couple of examples as well. So polynomials, I'm going to say 7x to the 9th plus 2x minus 14. That's a polynomial. 17, that's a polynomial. X to the 124th power, that's a polynomial. How about the square root of 5 times x? That's okay, as long as the x is not in the square root. Okay, notice the square root ends. X cannot be under the square root, but the number can be. That's okay. Something like 3x plus 4. We could have 17x to the 5th plus 2x cubed minus 9. Okay. The other thing we can't do, we can't have x in the denominator. So I can have 1/2 x, that's okay. Not polynomial would be the square root of x or 1 over x. Okay, so that's what we have to look out for. It's a polynomial as long as the x is not under a square root or in a denominator, and x can be raised to any power that is a whole number. Okay, so we can't have x to the -4. We can't have x to the 2.7. It just has to be a whole number. So those are all examples of polynomials. I'll give you a chance to type yours into Edpuzzle. Okay, so we have here a list of polynomials, and we're going to look at how can we classify these. And there's two different things that we're going to look at to classify these. We're going to look at the degree. The degree means the exponent, and we're looking for the biggest exponent on a variable. So we're looking for which x has the biggest power, or if maybe our variable is an x, maybe it's t, which t has the biggest power. Okay, the second thing we're going to look at is the number of terms. And remember, terms are separated by addition or subtraction. So really, we're going to say how many addition or subtraction signs are there? Plus 1. So in our first example here, our polynomial is just 5. Now, it doesn't have an x. That's okay. A polynomial doesn't have to have x. Our degree here, if there's no x, then the biggest exponent is 0. So our degree here is 0. If our degree is 0, we call this a constant function, right? We saw that on the last couple of slides. The number of terms, there's no pluses or minus. That means there's just one term. And if there's one term, we call this a monomial. Mono meaning one. Okay, our second polynomial here, we have x plus 4. Degree, what is the exponent on my variable? Well, my variable doesn't have an exponent. That means it's an invisible 1, right? Everything is raised to the first power. So our degree here is 1. This is linear, like the equation of a line. How many terms are there? Well, there's x plus 4. So there are 2 terms here. If there are 2 terms, we call this a binomial. Bi, like bicycle, means 2. Okay, our next one, 4x squared. Degree, what is the exponent? The biggest exponent on a variable is 2. If our exponent is 2, then this is quadratic, like we saw in chapter 4. How many terms are there? There's no addition or subtraction, just one term. If it's one term, then it's called a monomial. So these two classifications are separate. The degree doesn't have anything to do with the number of terms. And the number of terms doesn't have anything to do with the degree. We're looking at them separately. Okay. In our next polynomial, the first thing that we're going to look at, let's look at the number of terms first, so that you can see they're not dependent on each other. The number of terms, I have 1, 2, 3 terms. If I have a bicycle, but instead of 2 wheels, it has 3 wheels, I call it a tricycle. This is a trinomial. Trinomial. Okay, and then the degree, the biggest exponent. Now I have an exponent of 1, an exponent of 2, and an exponent of 3. So which one of those is the biggest? The 3 is the biggest. So we call this cubic. Cubic means it has an exponent of 3, like x cubed or x to the 3rd power. So this is cubic. That comes from a cube having 3 dimensions. Right? This is a 3-dimension. 3D is a cube. So x to the 3rd is cubic. Kind of like the area of a 4-sided figure is quadratic. Okay, so it relates back to geometry a little bit. In our next example, we have 2x to the 4th plus 5x squared. I want you to try this one. What is the degree and the number of terms? And then we'll name them together. So we should get a degree. We have 2 exponents, 2 and 4. The biggest one is 4. And if we have a 4th degree, it's called quartic. Quart, like a quarter, is 1/4 of a dollar. So quart means 4. Quartic means 4th degree. And then the number of terms, we have 1, 2 terms. So you should know this name. We have one from above, is a binomial. And our last one here, we have exponents of 5, 2, 1, and 0. The biggest of that is 5. And if I have twins, but there are 5 of them, we would call them a quintuplet. So this is a quintic polynomial. Quin means 5. So that's constant, linear, quadratic, cubic, quartic, quintic. Now you should definitely know these first ones up to cubic. These last two, if you just want to call it 4th degree and 5th degree, I'm okay with that. But vocabulary wise, if I say it's quartic, you should recognize that that means 4th degree. Okay, number of terms, this one has 1, 2, 3, 4 terms. There's not a special word for that. We would just say 4 terms. And then we could say 5 terms and 12 terms. Any degree higher than that, x to the 7th, there are special words, but we would just say 7th degree. Okay. So now we can classify some polynomials. Let's try it. I want you to go ahead and try these, put them into Edpuzzle, and then I'll show you the answer. Okay, so even without writing them in standard form, you should be able to classify them. But what does it mean to write it in standard form? Remember, this is the very beginning when we defined polynomials. We said we start with the biggest exponent and we go down. So this is also called descending order. I'll write that in a second. We start with the biggest exponent, which was 9x squared, and then 3x, and then 5, called descending order. Like if you're descending a staircase, you're going down the staircase. So descending order means the biggest exponent down to the smallest. We can say degree is 2. So this is quadratic. And there are 3 terms. So this is a trinomial. Go ahead and try part B. Again, starting with the biggest exponent, that's x to the 4th. There's no x cubed, so then we do x squared, and there are 2 of them, so that's plus 4x squared. We went 4, 3, 2, 1. That's plus 4x. And finally, minus 12 with no x. So degree, that's the biggest exponent, is 4. That is quartic. And there are 1, 2, 3, 4 terms. We don't have a special name for that. We would just leave it as 4 terms. If you wrote that it has 5 terms because you didn't combine like terms, that's okay for this, okay? But you should always, always simplify before naming your polynomials. Okay, what about graphing these? Well, we've already seen the graph of something x squared, right? If I have a positive number times x squared, let's just say we have y equals 2x squared. What does that look like? Well, we know x squared is a parabola. That was the whole project that we did at the end of the semester. So that's going to look something like this. Okay, what about when a is negative? What if I had y equals negative 2x squared? Well, the negative makes it upside down. So instead of opening upward, it opens downward. Okay, now this is going to be true whenever we have an even degree. So when the exponent is an even number, we'll always have something in this shape. Okay, but what about when that exponent is odd? So let's look at what happens when we have y equals 2x cubed. Now you can try this on your calculator if you'd like to, but if you graph y equals 2x cubed, it looks like someone doing the disco. Okay, now it's very important the right side goes up and the left side goes down, because what happens when we have a negative coefficient? Well, just like before, instead of pointing up, the side that pointed up is going to point down, and the side that pointed down is now going to point up. So what we have is the opposite disco. And that's going to be true for any odd degree. X to the 5th, x to the 7th. And what we have to look at is what's called the leading term, which means just the term with the biggest exponent. And that's all we need to look at in order to know if the graph will be shaped like one of these 4. This is when our coefficient is positive, and this is when our leading coefficient is negative. So all you have to know is that leading term, and then you can know exactly what shape your graph will be. Now that doesn't give us coordinates. Okay, we can still make an XY table for that, where you pick a value of X and it gives you a value of Y, just like we did with lines and quadratics. But by knowing how the graph will look, the shape of the graph, before even having to do any of those calculations, you'll be able to sketch and understand more about this graph with just one glance, without having to do computation and without your calculator. Okay, there's going to be a game that we play where we're going to pose as different graphs, and we're going to use this strategy. by just looking at the leading term. Okay, so in summary, the end behavior, that's what's happening with those arrows. If our exponent is even, so this is the degree, is even, or if the degree is odd, and this is when our leading coefficient, let me try that again. Coefficient is positive or negative. So this is the graph we just did. If I have positive even degree, that would be something like 2x squared. If I have a negative even degree, that'd be something like negative 2x squared. If I have a positive odd degree, that would be something like 2x cubed. And a negative odd degree is something like negative 2x cubed. Okay, so what does it mean up, up? Well, 2x squared went up to the left and up to the right, up, up. Negative 2x squared, down, down. Notice I'm saying where the arrows are pointing. 2x cubed, down, up. Negative 2x cubed, up, down. Okay, so let's try this. Consider the leading term of each polynomial function. What is the end behavior of the graph? And then you can always check with your graphing calculator. So the first thing to do is find the leading term. We'll do A together, and then I'll have you try B. The leading term is the one with the biggest exponent. So here we have two exponents, 3 and 1. 3 is bigger, so we have 4x cubed. 4 is positive, and x cubed is odd. So odd means our hands are going to go opposite directions when we dance. It means our ends are going to go opposite directions. A is positive. I think of A being positive means right hand up. Okay, notice positive, the right hand always goes up. So it's odd. The right hand goes up, the other hand goes down. Okay, so the end behavior is down and up. Try part B. First thing is to find the leading term. That's exponent of 0, 2, 3, and 4. 4 is the biggest. So we have negative 2x to the fourth. Our leading coefficient is negative, and this is even. The way I like to think about that, if it's negative, that means right side down. And it's even, so they're both going to go the same direction. So this is going to be down and down. Okay, and the last thing to cover is just a quick review of factoring polynomials. So remember, always factor the greatest common factor first if there is one. If there's a negative in front, if our leading term has a negative, you're going to factor out that negative. So your GCF would be negative in that case. You can use any method. We talked about several of them. The way that I usually show it is the X method or the diamond method. And then we also have some special polynomials, the perfect square trinomials, and the difference of squares that we had special ways of factoring. So go ahead and try this, and then we'll go to the answer together. The first thing I'm going to do is say that our greatest common factor here, I have x cubed, x squared, and x, so I can factor out an x from all of those. X times x squared minus 2x minus 15. And then I need two numbers that multiply to negative 15 and add to negative 2. It's going to be 5 and 3, and the bigger one needs to be negative in order to add to negative 2. So I still have that x, but now I have an x minus 5 and an x plus 3. That is the factored form. Okay. I have two more for you to try factoring, and then that will be the end of the video. So the first one, the one on the left here, again, I have a GCF of x. So I have x times x squared minus 36. You can use the x method, but this is a difference of squares. So it is a difference, meaning it's subtraction of squares. Always check that it's subtraction. X squared minus 6 squared. So that becomes x minus 6 times x plus 6. And the one on the right, again, we have a GCF of x. This time, I can recognize this as a perfect square trinomial. If you don't recognize that, if I have two numbers that multiply to 16 and add to 8, they are the same two numbers. That's what can clue you in. That's a perfect square trinomial. So that becomes x plus 4 squared. Okay. On your own, do these practice problems, submit them on Blackboard as a PDF, and I will see you not this coming class. Remember, I'll be out this coming class, but I will see you next class after. So I won't see you Thursday and Friday, but I'll see you the following week on Tuesday and Wednesday.